Trig Identities. So as we're working through problems that involve trig functions, oftentimes it will be easier to work through the problem if we can change the form of it. And this is where the trig identities come into play. And there's quite a few of them. First off, all the trig functions can be written in terms of sine and cosine. So for instance, tangent theta is sine theta over cosine theta. Cotangent theta equals cosine theta over sine theta. Secant theta is 1 over cosine theta, and cosecant theta is 1 over sine theta. And it's not too uncommon if you're faced with a problem and you're not sure where to go and you feel like you're stuck and it involves trig functions. Sometimes it's very useful to convert them all into sine and cosine, and maybe some things will cancel and simplify and things might work out for you there. So that's one option there. Also, we have that the reciprocal of any trig function is just another trig function. For instance, secant theta equals 1 over cosine theta. But also this works the other way around, where cosine theta is 1 over secant theta. Cosecant theta is 1 over sine theta, but also sine theta is 1 over cosecant theta. And then finally, cotangent theta is 1 over tangent theta, and tangent theta is 1 over cotangent theta. The next set of identities are called the Pythagorean identities, and the reason for that is they're based off the Pythagorean theorem. Remember that cosine and sine are determined by the x and y coordinates on the unit circle. The equation for the unit circle is x squared plus y squared equals 1. So this gives us the trig identity that cosine squared theta plus sine squared theta equals 1. Of all the trig identities, if you only remember one of them, this is the one that you should remember. This one comes into play more often than any of the others. Now, this is not the only Pythagorean identity. We can get the rest of them by taking this equation, and first we will take this equation and divide each term by cosine squared theta. And then what we see in this first term, cosine squared over cosine squared, that's just 1. In the next term, we have sine squared over cosine squared, which if we factored out that squared, this would be sine over cosine, which is tangent. So that's tangent squared. And then over here, we have 1 over cosine squared. So this is going to be secant squared theta. So this gives us another trig identity that involves secants and tangents. And then if we did this same thing, but instead of dividing by cosine squared, we divided by sine squared, this would end up being cotangent squared theta plus 1 equals cosecant squared theta. So these three are the Pythagorean identities for the trig functions. Cosine squared theta plus sine squared theta equals 1, 1 plus tangent squared theta equals secant squared theta, and cotangent squared plus 1 equals cosecant squared theta. Another fact about the trig functions is all of them are either odd or even. And so sine theta is an odd function, which means that sine of negative theta equals negative sine theta. So if we have a negative sign on the inside, we can move that to the outside. Tangent has the same property. Same with cotangent. And same with cosecant. The other two trig functions are even, which means if we have a negative sign on the inside for cosine, it actually is irrelevant. It does not change the value whether it's a negative in there or not. And the same thing for secant. And the final set of identities that come up fairly regularly are the angle addition formulas and double angle formulas. And so if we have sine of A plus B, this is going to be sine A cosine B plus sine B cosine A. Cosine of A plus B is cosine A cosine B minus sine A sine B. And then also we have our double angle formulas. Sine of 2A is 2 sine A cosine A. And cosine of 2A is going to be cosine squared A minus sine squared A.